So next we're going to be visiting about the horizontal shrinking and stretching of graphs. This is either, moving a graph, like shrinking it in, or stretching a graph out. One of those two things. And this is, again, when you're dealing with the horizontal, counterintuitive of what you think it should do. All right, let's read the rule. It says, consider a function, a parent function. Let a represent a positive real number. If that number is greater than 1, then the graph of y equals the function evaluated at ax. You're going to know it's a vertical stretching or shrinking if you have something like f of x equals 3 times the absolute value of x. That was on the last example, versus now, if you have something along the lines of g of x equals the absolute value of 3 times x with the 3 inside there, that means we're going to have a graph now that is shrunk horizontally by a factor of 1 over a, or 1/3 in that case. Okay, so you're going to shrink it in if this is a number, if this a number is greater than 1. Okay, if a is a fraction between 0 and 1, then the graph of y equals the function evaluated at ax. So this might look something like h of x equals the absolute value of 1/3 x is going to be the graph of your function stretched horizontally by a factor of 1 over a. Okay, so it's going to be the reciprocal of that fraction between 0 and 1. So this one would actually be stretched horizontally by a scale factor of 1 over 1/3, which is 3. That's kind of wild, okay? Now, this is a good thing to know for any of our key points x, y on the graph of a parent function. The new key point, which that says it's x divided by a, comma, y, is on the graph of y equals our new function, okay? Let's look at example 5. Now, this little TP shape for our function, that's not one of our widely known parent functions. We don't really even know what the equation for that would be. But it is a function because it passes the vertical line test. Therefore, we can apply these rules to graphs. All right? Now, we don't know what the equation is, but they say on part A, they want us to graph y equals the function evaluated at 2x. And so if we pick out some key points on our given function over here, let's label some of those key points. Let me do that in a different color. Let me do that in maybe blue, okay? A key point down here is -4, -2, all right? Up here we've got -2, +4. And over here we have 2, -2, okay? Now, to find some key points here, I'm going to take the old key points. Let me kind of recopy those. -4, -2. -4, -2. Uh-oh, what did I do? Hold on, time out. Sorry about that. I had inadvertently hit that button down below to open up my web browser when I was reaching for my eraser. So anyway, hang in there. Okay, then another key point that we have labeled on our graph is -2, 4, and then 2, -2. All right, now on this one, our value for A is 2. And so if we come along here and divide each of these by A, divide by 2, that'll give me some new key points on my graph of y equals my function evaluated at 2x. Okay? That's now going to have a new key point at -2, -2, at -1, 4 for that one, and at +1, -2. So when we plot these points, -2, -2, 1, 4, and 1, -2, you can see in comparison to the original function, the black one, how my purple graph has been shrunk horizontally, like squeezed in, by a scale factor of 2. Okay? Let's see. Orange would be good. For the next one, okay, where the A value is 1/2, essentially what that does is it takes each of these key point values. Let me just show you here. It would take the -4 and divide it by 1/2, which is the same thing as taking the -4 and multiplying it by 2. Okay? So my new key point on the graph for B, okay, let's see, that one will now be, and actually we're multiplying by 2 is really what we're doing here. That I'm now going to have a key point on my new graph at -8, -2. The y doesn't change, okay, just the x. For this one, multiply that by 2, and we have -4, 4. And multiply this one by 2, and we have +4. That's for this one right here. We have +4, -2. Okay? So if we graph each of those, -8, -2, -4, 4, and 4, -2, you can see that I'm going to try to draw straight lines here. Not too bad. And wow. Okay. And they make that sound when you graph them too, okay? This is the graph of y equals the f evaluated at 1/2 x. And you can see in relation to the parent function, the black one, how it was stretched horizontally out by a scale factor of 2. All right, so that's how that will work.